Hey, now we're on, I guess, video 5 of lesson 4.1. I knew it would take quite a bit because this is a lengthy process doing systems of equations, and I don't think I've even got all the homework assignment that I'm actually doing. I'm only doing up through 34, I believe, and the assignment goes through 55. But at least I am getting examples of every type of problem we would have on there. Okay, I'm going to start with number 30 because I've already done through 28. Luckily, these two are already in standard form, so things are going to line up nicely. In case you haven't watched the other videos, we're doing linear combination, also known as elimination. And I'm going to try to eliminate one of the variables, either the x or the y, and I need them to be additive inverses to eliminate them. If I was going to do x, I could make these both 12s by multiplying that by 2 and that by 3, but they wouldn't have different signs. I'd have to put a negative on one of the multiples, on one of the things I'm multiplying by. Y's already have different signs, so I think I'm going to work with the y's and eliminate them. Common multiple of 3 and 5 would be 15. So if I multiply this one by 5, that gives me 15. Actually, negative 15. If I multiply this by 3, that gives me positive 15. Negative 15 and positive 15 will cancel later for me. So now we're ready to multiply. That's 30x minus 15y equals negative 15. 3 times 4x is 12x plus 15y is equal to negative 27. 30x and 12x makes 42x. Ooh, that's big. Okay. And negative 15 and negative 27, that is negative 42. It's going to work out nicely. I divide by 42. X is negative 1. Now I could take this negative 1 and plug it in for x in this equation or the top two equations, any equation I want, because I don't necessarily have one that says y equals whatever for me to plug that into. So I'm going to choose this one right here. I like it because it doesn't have any negatives on the x or y's. Even though I'm going to have a negative in here after I plug the negative 1 in, at least my y term is still positive. Now I'm just going to solve for y. And I have an ordered pair. Negative 1, negative 1. Okay, the next two. Here we go. I have on number 32, negative x plus 3y equals 6. 3x minus 9y equals 9. I believe working with either the x's or the y's, either one is not really going to matter on this. So I believe let's go with x's. We've used y's a lot. I think I'll eliminate the x's. For 3 and 1, a common multiple will be 3. So I could times this by 1 and this by 3. That will give me negative 3x and positive 3x. That works out nicely because they're already additive inverses. So I'm going to go ahead and multiply. Make sure you multiply the one over here. A lot of people forget to do that. 1 times all these will be 3x minus 9y equals 9. And I'm going to combine them together. Negative 3x and 3x is 0. 9y minus 9y is 0. We don't have any x's and y's left. So it's kind of like when we were solving equations with just one variable. If we get a true statement here, it's going to be all real numbers. Well, infinitely many solutions. It's not actually all real numbers in this case. Maybe we'll get an example like that a little bit later, and I can explain that. But in this case, we have something that's false, and if it's false, let's hold on a second. It's uh-oh. There we go. If this right here is false, there's no solution. This is inconsistent. So it's empty set or no solution. Or we could say it's an inconsistent system. And earlier we talked about this when we were doing the graphing. If I was to graph these two equations, they'd be parallel lines. And that's why they're not intersecting, and there's no solution, no x and y that makes both true, because they run on totally separate x and y values. Okay. So if you do one and I think you'll notice right here that the x's and the y's, the coefficients, could have actually been made the same if I'd multiplied this right here by -1. And it's when they're the same that we run into these problems. Okay, it's either going to be inconsistent because they're parallel, or it may possibly be the same equation. You know, if these had both been 9s over here, well, we would have needed -9 on this one because of the negative out here. But if we end up with the same number on all of them, they're the same equation, then it's around top of each other, and it's infinite many solutions. And I'll show you how to describe that in the next problem. I believe this one is going to be an example of what I was talking about earlier. This right here is not in standard form. So to get it in standard form, I'm going to move the 2x. I'm going to subtract 2x from both sides. End up getting -2x plus y is equal to -5. And then on this one I have 8x minus 4y is equal to 20. I can work with either the x's or the y's. I think I'm going to work with the y's on this one. This seems like a lot of times what we work with. To have additive inverses on the y's, a common multiple. It's hard to keep straight common factors and common multiples. A common multiple will be 4. So I'm going to put a 4 right here and a 1 right here. That way I have 4y and -4y. 4 times this would be -8x plus 4y equals 4 times -5 is -20. And you can kind of see this coming together right now. These right here are the additive inverses of all these. So when we combine these together, I'm doing 1 times that now, in case you're wondering. We end up getting 0, 0 equals 0. And this is always true. But the reason why is because if I had multiplied this by -1, we'd have the exact same equation. So it is a consistent system, meaning that they actually share a solution. This actually shares infinite many solutions. But it can't just be any ordered pair. That's what's kind of interesting about this. There's infinite solutions, but there's only certain ones that will work. Not just anything works. And the way we find out what works and what doesn't is we take one of these and solve for y. We already had one of them solved for y right here. That right there shows the relationship or the function as to how to find the y value if you know the x. So because we can choose any x we want, we'll get a y value for each one, and there's infinitely many of them. But this right here describes the infinitely many solutions. It's the graph like this. Y-intercept's -5 and slope is 2, so every time I move over I'm going up 2. So I can draw a line through that. Line tool sure does make it easier. And that's it. So I hope the video helps, and I'll try to produce more for the next lessons.